Hey guys, I asked the community kind of what you guys wanted to learn next, and somebody mentioned that they wanted to know how to make the bullets go forward. Um, but instead of doing that, I'm going to show you actually a better way of handling things like bullets. I'll still explain how to do the bullet moving forward thing if you want to know. But yeah, let's dive right into it. So first, what I did is altered some of my variables here, the figures, so that it wasn't going to jump too high or whatever. So I have it at 5, 55, and 15. But anyways, if you wanted to make the bullet move forward, it's a very simple script. Don't worry about that. This is my second time recording, so you'll see that. You could go to like the kill object script, which is on the bullet. I know it's a terrible name, or a terrible place to put your move forward script, because this is not what the script is supposed to do. But you would essentially have it say like transform. You could do, well, I guess it is a rigid body, so you could use the rigid body to go forward. But let's say you do translate, and you'd have it go transform dot forward times some sort of move speed variable. And then you'd probably do it times time dot delta time. Oops, not fixed delta time. I mean, you could do that, but just delta time. And what this is very similar to this, essentially, right? Except for it's not waiting for you to do an input of a button. It's just going to move you forward every single frame. In fact, I will just put it like 15 so you can see what happens. And let's see what happens. Go back and boom. There goes our bullet. Bye. See you later. Interesting. Now that's cool, but the problem is if we rely on physics to handle our collisions with fast moving objects like bullets, we're going to run into a very interesting issue. Now to illustrate this, I want to let's create an object. Let's create a cylinder. All right. Now, if we look here, down here, you'll see I have the cylinder. I'm calling the cylinder. Let's call it enemy for now. Maybe we'll use it later. So this enemy, I keep doing that. So all right. So here we are. Let's say this is a bullet, or it's moving as fast as a bullet. It's gonna go like that, right, through our guy. At least that's what you expected it to do, and you expect it to, as it passes through, to collide with this guy and throw him off, so that he gets hurt. Let's move. Hold on, let's move him closer so it looks like that too. You expect that to happen, but the problem is the way the physics engine works is it calculates collisions every single frame of your computer. So your computer, let's say, runs at 60 frames a second or 30 frames a second or whatever. It's going to calculate where this thing is 30 frames a second. So like do boom 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 boom, right? Now for something like a basketball, which is like boom 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 boom, not moving very slow. So the chances are that within a given second, it's going to be somewhere in this collision area of this character, and it will register that it's colliding and respond, right? But if it's an object that's moving really fast, like a bullet, it could be like frame, 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 or frame, 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 and completely miss the collision with this thing because it registered, where am I here? Anything colliding with me? No. Where am I here? Anything colliding with me? No. So it'll never register that you actually got hit by a bullet. And that would suck, right? Because you want to hit that guy. You want to kill that enemy. So instead what we're going to do is, let's return this enemy to, let's reset his position. Where is he? He's far below. And we're going to look down at him by pressing this button. And let's move him out a little bit, just so we can see him out there. He's just chilling out there. So what instead we're going to do is not use a bullet. We're going to use something called a raycast. So let's open up your movement script in MonoDevelop. You can close this kill object script. We don't need them anymore. And what we're going to do is we're going to say here, right, where it says get button.fire, we're not going to instantiate a bullet. We're going to do a raycast. And this is how you're going to do it. First, we're going to create a raycast hit variable. And we can call it hit. That's all you got to do there. You could take this out and put it up here if you wanted to expose it, but we don't necessarily have to do that at this point. We're just going to keep it here because this within these brackets is the only time we're ever really going to use it, at least for now. We may need to move it out later, but let's not worry about that. Then we're going to go if physics dot raycast. And as you see here, there's in this yellow box, there's these different solutions, and you can click through them like this, or you can use the you can use the arrow keys. Why is that not working? Weird. Maybe you have to be. Oh, here we go. Raycast, and then you do a little parentheses, and now you can cycle through. This one has 12 different solutions. So these are solutions for how you can kind of solve the part in the parentheses. And you can just find the one that you like. So let's create one with a ray. So we'll do ray. Actually, no. Let's do this one. Let's do origin and direction. Yeah, origin, direction, and hit info. Unless there's one with, here, this one. We're going to do that one. So we're going to do an origin, which is going to be my muzzle dot position, just like the bullet down here. We're going to have the ray come from the bullet, or from the gun. Then we're going to do, uh-oh, we lost our thing. That's no fun. Again, I'm cycling with my arrow keys. Direction. Let's do transform.forward. That's the direction we want to go, right? Now this next part gets weird. Where is it? This out raycast hit info. So essentially what this is asking for is you to use your hit, your raycast hit variable, and you have to put the words out before it. Why do you have to do this? Not exactly sure, but you do. So we're going to say out hit, and then we're going to say mathf.infinity. And what this is this is essentially a class, again like movement script or whatever, and there's something on it called infinity. Maybe it's a variable or a function, but in this case it just represents infinity. So that's cool. We're going to have our raycast go on forever. Let's put two closing parentheses, Jesus. Bracket. And we're going to have this say debug.log. You hit something. So this is basically saying if this thing returns true, which essentially means if you hit something, then you run whatever in these brackets. And you could do like else debug.log you missed or whatever. But let's break this down even further. So what we are doing is, although we are using the raycast or the physics engine, a raycast is very different than an actual physics calculation in terms of collision, because what we're doing is we're essentially drawing a line from between 2 points, or from one point, in this case my muzzle dot position, forward right here for infinity, and it's going to hit something. It's going to kind of see if there's anything in between this line. So if it was between two positions, it would say if there's anything in between those two positions. In this case, we're saying if there's anything in the way of my like laser, which is going from my position forward for infinity. It's like a laser pointer. And if anything comes in front of that, it's going to register it as a hit in our raycast hit object. Now, we don't want it just to say like, oh, you hit something, because that's not very useful. We want to know things like, where did you hit and what did you hit? And you can do that with this raycast hit object. So what we're going to say is if hit dot transform. So if this is accessing the object that you hit, so the transform that you hit, hit dot transform dot tag is equal to enemy. Whoops, enemy. Then we'll do something in a sec. So basically, this raycast hit object, which is getting spit out here, is holding on to whatever object went in the way. We're going to access this object. We're going to then access its tag, and we're going to check if that tag is enemy. So to explain this, let's go back to Unity. Let's find our enemy guy up here, and you'll see up here it says tag, and it says untagged right now. We are going to add a tag. Sorry, you won't see enemy here. I did because this is my second time recording. But let's go to add a tag. This is how you would do it. And you might see something like, you'll probably see something like this. Or, anyways, you can add enemy like that. But don't forget, you have to go back to your enemy and re-tag him as enemy. I know you went from here to do add tag and it should have added it to your guy automatically, but no, you have to go back and add it. So now look, our enemy is tagged as enemy. So now he's going to know that not only is there an object in our way, but now we know we hit an enemy, and that's cool. So maybe what we want to do is if we hit an enemy, we want to, I don't know, instantiate something called blood, and we'll do it at hit.point, which is kind of like saying hit.position, but for a raycast hit, they call it a point. So the point where that ray, that laser hit the object, that bullet in this case, hit the object, or the enemy. And we're going to, you can say hit.transform.rotation. Rotation? Oh, dot quaternion? What is in this object of mine? Local rotation. Nah, yeah, whatever. I think you can do rotation. I think my thing's just messing up. Cool. Uh-oh, though, we don't have a blood object. So let's copy that, and we're going to put that up here, and we're going to say public, we can say transform, and we'll call this blood. I said blood. Okay. Cool. And we want to make it public so we can see it in the inspector. So save, go back here, and now what we're going to do is we're going to create a blood effect, which is going to be awesome. So let's go to game object, create other, particle system. Boom. You'll see all these pretty little things going, and that's really nice. I'm going to move it forward a little bit so I can see it. Let's move it back a little bit too. And this is just so I can see it. This has nothing to do with it in the end. So first we're going to make it red. Obviously it's blood. We can make it speed. That's cool. Maybe we'll reduce the size of those. Whoa, not make it bigger. That looks more like blood. 0.5. We will have some inherent velocity. What does that do? I don't know. Woo. Let's leave that be. Gravity multiplier. There we go. Perfect. Blood. Alright. You can leave these other things for now. Let's go to our emission. It's at a rate right now, so it's going to spit out it like this, which is cool, I guess, if you're like bleeding constantly. But what we want to do is instead do a burst. And we're going to do a burst of 30 particles, and we're going to change this number from 10 to 1. So it just goes like that. See? Oh, not like that. Like, see? Boom. There we go. Sorry, change it to 0. I think that's better. And I think we need to change our start lifetime to, oh no, sorry, our duration, I think, to 1. See? There you go. The duration is like for the entire particle system, and I think the lifetime is for each particle. So if we turned up the lifetime, the particles would last longer. Like if we turned it up to 60. But of course, we need to turn this up to 60 for it to really work. Sorry, let's keep it at 6. Let's keep it simple. There you go. Cool. 6. 6, 6. Here are the variables. Sounds good. Shape. It's in a cone right now, which I guess is appropriate. But I'm going to do a sphere just because I like that. And random direction's cool. Now what we want to do is say collision. Now this is completely unnecessary, but I like to have it collide with things in the world because I think that's cool. See how they go bouncing the particles? I think that's kind of rad. That's just me, but and you can change these variables to make it bounce less if you want, like that. A little bit less bouncy. Let's make it a little bit less, actually. Alright, 34, whatever. And now you can send collision messages, so you can have it tell you every time a particle hits something. But we don't need that right now. So yeah, okay, we got our particle. It looks good. It's splatty. It's bloody. Let's call this thing blood. And let's drag it over here. Drop it in there. We got a blood particle. Now let's go to our player. Drag this thing onto our blood right here. Click apply. But let's do something else. Let's duplicate this. Actually, we don't have to duplicate this. We've already created a blood prefab, so now we can change this prefab. Let's call this dirt. Let's change the color to, I don't know, kind of a grayish color. And let's have it, this gravity multiplier be less. Ooh. Let's turn down its start speed maybe. It's kind of boring, right? Whoops, click back at the dirt, sorry. Start speed is 1. Okay, cool. Boring as heck, nobody cares. Let's change this to a cone, just cause. Now, instead of clicking apply, we won't want to do that because then that would apply to the blood. We want to click, drag, create a new prefab called dirt. Now this is connected to the dirt object, not to our blood object. Cool. So let's delete this guy. Bye-bye. Let's go back to our script. And let's add something called public transform dirt. And down here, we're going to say, we're going to copy this enemy part, paste it here, and we're going to say, remove that, and we can just say else, which is kind of like saying otherwise. And instead of blood, we're going to say dirt. So essentially what we're doing is we're saying, if you shoot a raycast and it hits an object, yay, this part's going to run. Now, within that, if the object you hit is tagged as an enemy, let's instantiate some blood at the point that you collide with, that the ray collides with that enemy. and we're going to have it adopt the rotation of that enemy. Otherwise, if you haven't hit an enemy, let's instantiate some dirt particles at the place where the raycast hit that object, and we're going to have it adopt the rotation. Otherwise, if you didn't hit anything in the raycast, then we're going to say you missed. So save that. Let's go back and watch the hilarity ensue. Alright. So now when I click, it says you missed, you missed, you missed. But blood. Blood, 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 blood. Blood. Blood, 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 blood. Blood. Oh my gosh. I think I broke it. I totally broke it. I'm sorry. I don't know why it's doing that. Oh, let's go back to our blood. Our blood needs the kill object script. Duh. As does our dirt. So drag those onto the prefabs. Now it should go away. But before we do that, let's duplicate this enemy. Let's move it over here a little bit. Let's make it bigger so we know that's that. And let's remove its tag of enemy. So now what should happen, if I hit this object, blood, right? Blood, blood. If I hit this object, uh-oh. The variable dirt of movement script has not been assigned. You probably need to assign the dirt variable. Ah, duh. That thing's empty. So let's grab our dirt, drop it on there, apply it to the prefab. Yay. So boom, blood, dirt. Now why is it doing that? I don't know. Let's find out. Why is our object doing that? Emission. Maybe it's because it's got speed. Oh, it's because it's rotation. So let's go back to our script. Instead of hit.transform.rotation, we're going to say quaternion. Whoa. Weird name, I know. QUATERNION dot identity. Do I know what that means? Nope. But I use it all the time. Sweet. Now let's try that. You want to do that for both the blood and the dirt. Boom, blood. Blood. And dirt, 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 dirt. Still having the same problem with it acting crazy. So maybe what I want to do is, let's give this a, say quaternion.0. Don't know if that'll work, but we're going to find out. Oh my gosh. And quaternion.0. Let's save that. Oh, that didn't work. Okay, go back. We're going to say hit.rot. We're going to say vector3 dot Euler angles dot I don't know. Let's just say transform dot rotation. Alright, we're going with transform dot rotation. Come what may. Let's do this. Pew, pew. I missed. I missed. Oh, there we go. Why am I missing the... There he is. I don't know why I'm making the sound effect. Oh, that's why, because I don't have a sound effect. Why is that? Because the sound effect was attached to my bullet, and I'm not creating bullets anymore. So what we need to do is go up to here, and we need to say, let's do it down here, whatever. Public audio clip, gun hit sound. Okay, gun hit sound. This is called camel case, lowercase here, uppercase, uppercase. And then we're going to say down here, if you hit an object, it doesn't matter if it's an enemy or not, although you could put it in here if you wanted to specify. We're just going to have it make the sound if it hits anything. We're going to have it do audio.play one shot, so that means play it once. Gun hit sound. Boom. Go back to Unity, after we save, of course. And, of course, our gun sound needs to be filled, so let's do ricochet. Oh man, this is working out so perfect. Apply. And then let's press play. Now you could tweak the particle effects to make them better. These are clearly inferior in every way, shape, and form. But that should get you at least started with raycasts. And that's cool. Ah! Ah! So what we could do, if you guys are feeling up for it, is let's alter our script a bit. Let's say it's up here where the raycast hit is. Let's do another thing called a ray. And we're going to call this Ray. Pretty cool name. And we're going to say that Ray is equal to new vector3 dot we're going to say vector3 dot forward, which you could let's do this vector3 0 0 and 1. Now you have to put this new in there in C# for a lot of things. Now the reason for this is because it's kind of like you're instantiating something, like you instantiated the blood in the dirt, but you're instantiating an kind of virtual object called a vector3. If you just said this, it would say that ray is of the type vector3, which it's not. It's a ray. So we would be like resetting ray to a different data type, and it would be like very confused, and it would be like, what are you doing? So instead what we're saying is, no, it's like the same thing as this object here. It's not a vector3, it's a ray, but it's like the same basic thing. I know, terrible example, but let's see if it works. Copy ray, and let's put it, instead of transform.muscle, ooh, wait. Sorry. We don't want that. We have to do new ray. And how do you construct a ray? You give it an origin and direction. Cool. That's the same as this. Molto bene. So let's remove that. Put it here. Awesome blossom. Now let's take ray. I just like saying ray. And put it here. Now we got physics.raycast, use this ray, which is equal to this blah blah blah. And you might be saying to yourself, Eric, why are we doing that? That seems like a waste of time. Well, my young Padawan learners, it's so we can do this. Instead of saying debug.log you hit something, which is super exciting, we can say debug.drawRay. Oh damn. Using ray. And we'll give it a color dot white. Right? Very exciting. So if you shoot, basically, we can actually move this out. We can move that up here because it doesn't rely on the raycast. If you press the fire button, ooh, sorry, yours looks like this. If you wanted it to fire once at a time, like you'd use get button down, which So why don't you write get button down? Anyways, so if you press the fire button, it's going to draw a ray, so you can see it in the debug window. Then if you hit an object, what we could do is say, if you're hitting an object, we'll have this, instead of drawing white, we'll have it draw red. And if you're hitting dirt or whatever, we're going to have it draw green. And otherwise, you're just a sad sod. So let's see what happens. Oh gosh, I created a bunch of errors. Let's break them down though. Best overloaded match. Ray. I have some invalid arguments. Oh. I think because we're using this mathf.infinity. Let's check. Raycast, you can use array. What else can you use? Distance. Is there one that uses array, distance, and hit? Ray, hit, distance. Ray should be okay. What was the error? Oh, it's our debug.drawArray. I'm sorry. What did you want? You want to start? No, I thought you just wanted to. Oh, that's funny. So we can copy this in here. Right? We could do that and just copy and paste it everywhere it says ray for these debug.drawArrays. But what we're going to do instead is say ray dot origin, ray dot direction. Now, why did that work? Well, because array is essentially an object that houses a origin and a direction. So the same way we could use ray to replace the object or the origin and direction down here, we could use it to replace it up here, but we can't just use the object because the drawArray function doesn't recognize a ray. It only recognizes an object or an origin and a direction. So what we did instead is we put the ray reference in here, but then we use the dot syntax right here, the period, to access parts of that object, of that ray object, which, as we see here, included a position and a direction. So that's kind of cool. So you could actually do that for any of your own scripts as well. And it's now smart enough to recognize that. So if we said like, let's say custom object like this, and then you had a integer called I, you could then say custom object, oh actually sorry, getting at least a little confused here, but if we copy to paste that, let's bring it down here. We could say custom object int I, very cool. Now you could say up here custom object co equals new custom object, right? We don't have any parameters down here. It's just a blank object. But, so we don't have to do anything. And then we could say co.I equals 5, right? Because we're accessing the I variable of that co function or object. Now I'm probably doing this a little bit wrong. We might have to do like void, or maybe class. There we go. Class, object, custom object. And now it works perfectly. Very cool. And you could also say this. I'm teaching you guys a bunch of stuff right now. You could also say, boom, int ix, whatever. No one has to know. Hmm. Never mind. Don't worry about that. We'll cover this stuff later. All right. So that's how you do it. We can delete custom object because we're not going to use it ever. But that's how you would do it in the future. Okay, back to our ray casting thing. So now we have these draw rays. Everything's cool. The moment we've all been waiting for. More errors. Perfect. Draw ray. Oh yes, because I did ray dot origin ray. I'm so glad I named it ray dot direction ray dot origin ray dot direction. Sorry guys, this got a little crazy, but now you know about dot syntax and what you're actually doing when you use dot syntax. Okay, now let's see what happens. So you can sort of see a little bit of red down here when I hit, see? It's like a little flash of red and a flash of white, like that. But that's not very helpful because you can barely see it. So instead what we're going to do is say color.white, and then for our duration we're going to give it, let's give it 10 seconds, so 10.0 f, right, because it's a float. Copy that. Let's paste that down to our other one down here, comma 10.0 dot or 0.0 f, geez, comma. So you do it after the color. Save it. Now watch. Boom. Isn't that cool? Now notice it's not showing up in the screen up here. It's only showing up down here in your scene because it's a debug ray. We're not actually drawing this in real life. We're just drawing it down here so that when we're developing we can see, are we actually shooting the ray in the direction we're supposed to be. And it looks like we are in this case. So that's kind of cool. Alright. Well, that should be more than enough for this first round, or for this episode. Let me know what you guys want to learn next. Let me know if you have any questions, if things are broken for you. I apologize if they are. But yeah, good luck.